Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at finding the area of quadrilaterals. So a quadrilateral is just a four-sided shape, and you're probably familiar with finding the area of the first three: a square, a rectangle, and a parallelogram. So just be aware whenever you see H in a formula in measurement, it always means perpendicular height, the height at 90 degrees, not the slant height. So some shapes for which you may not have found the area before: kite and rhombus, so we can use the same formula for both. So note this here is a kite because pairs of adjacent sides are equal. If all four sides are equal, then it'd be a rhombus, but you can use the same formula for a kite and a rhombus. X and Y are the two diagonals, so you multiply together the two diagonals and divide by 2. This last shape here is a trapezium. You know it's a trapezium because it has only one pair of parallel sides. So A and B are the two parallel sides. Once again, H means perpendicular height. So let's look at some examples. So let's say we have here a square that's 1 meter by 1 meter. So its area is just 1 times 1, or 1 squared, 1 meter squared. Easy as. Now, 1 meter is actually the same as 100 centimeters. If you want to go meters to centimeters, you times by 100. So if I want to find the area of this square in centimeters, it's 100 centimeters by 100 centimeters. Well, 100 by 100 is 10,000. See, this square has area 1 meter squared, but also 10,000 centimeters squared. Therefore, there are 10,000 centimeters squared in a meter. Even though there are only 100 centimeters in a meter, there are 100 squared, or 10,000 square centimeters in a square meter. So when you're converting square units, everything here needs to be squared. So just note the rule is if you are going from a smaller unit to a larger unit, you divide, because there are fewer of the larger unit. If you're going from a larger to smaller unit, you times. But you must square these numbers called the conversion factors when you are converting square units, and I just explained why here. You also need to know what a hectare is. So hectares are used for very large areas. 1 hectare is actually 100 meters by 100 meters. So 1 hectare is 100 by 100 is 10,000 square meters. So rule is if you're going from a smaller to a larger unit, you divide. So here we would divide by 10,000. And going the other way, hectare to meter squared, we'd times by 10,000. Now, 100 meters is 0.1, or 1/10 of a kilometer. So 1 hectare is 0.01 kilometers squared. It's 1/100th of a kilometer. There are 100 hectares in a kilometer squared. So make sure you know how to perform these conversions. Let's now look at finding the area of a trapezium and a kite. So we'll start here with this trapezium. So we know it's a trapezium because it's got one pair of parallel sides. So we just need to know the formula. So the formula for the area of a trapezium, once we've identified it, it's H over 2A plus B. So for a trapezium, it's perpendicular height divide 2 multiplied by the sum of the two parallel sides. Sum meaning plus. So 17 plus 23 is 40, times by 8. Divide by 2, you get 160. Now when we're writing area, it's always going to be in units squared. So here we have a kite. We're going to find the area. So the formula for the area of a kite is xy on 2, where x and y refer to the two diagonals. So here I have one diagonal, but I need to find the other. So sometimes in measurement, you're going to need to use Pythagoras to find a dimension, like a side length or something, so that you can calculate the area. So if I call this C, note here I have a right angled triangle where C is the hypotenuse. So longer side is equal to square root of shorter side squared plus shorter side squared. So 10 squared plus 10 squared is root 200. I want to use this instead of the rounded version 14.14, etc., because I'm going to use this in a subsequent step and I want it to be accurate. So now that I have found the other diagonal, I've got 1, 2 diagonals. All I do to find the area is multiply them together and divide by 2. So putting that in our calculator, we get about 141.4. Now the unit's going to be centimeters squared. It's always unit squared for area. Now I'm going to use this symbol here instead of equals because it's not exactly equal to 141.4. It's just close to. This is a rounded answer, so I use approximately equal to instead. All right, let's now look at examples where we're finding a side length given the area. So whenever you are asked to find a dimension, like a length, width, radius, whatever, make sure you follow these steps. Write the formula, substitute in what you know, and then rearrange. So what do I mean by that? Well, here we're given a trapezium. We know it's a trapezium. These two right angles mean those sides are parallel. So I've got a trapezium, we have its area, and we need to find one of its side lengths. So we're going to follow these 3 steps here. The first thing we're going to do is write down the formula. So the area of a trapezium is always h over 2a plus b. Now we're going to substitute what we know. So we know, for example, the perpendicular height is 12. So I'm going to rub out h and replace it with 12 for perpendicular height. Now it doesn't matter which of the parallel sides I call A and which I call B. So I'm just going to say B is 19. So I'm going to rub out B and in its place put 19. Now we're also told that A, the area, is 192. So we can now solve this equation because we have only one unknown. So note that 12 over 2 is just 6. Dividing each side by 6, 192 divided 6 gives us 32 equals A plus 19. And of course that tells us that A is equal to 13 and we're done. All right, let's look at this question. The perimeter of a rectangle is 80 centimeters. Length is 14 centimeters more than the width. Calculate its area. So feel free to draw a diagram if you so wish. Now, in order to calculate the area, we need to know the length and the width because the area of a rectangle is just length times width. So we need to use the perimeter to get the length and the width. So what we're going to do is we're going to call this L for length and W for width. So we know that perimeter is equal to 2 times length plus 2 times width. The problem is we can't have an equation with 2 unknowns. We don't know how to solve this. We do, however, have a link between them. The length is 14 centimeters more than the width. So what I can do is write the length as width plus 14. See, then can rewrite length as width plus 14, and I'll have an equation with only one unknown because I know that the perimeter is 80. So expanding the brackets, 2 times W, 2 times 14, and we've got a 2W there. We now collect the like terms, so 2W plus 2W is 4W. 28 doesn't have any like terms, so I'll leave it as it is. So now I'm going to subtract 28 from both sides and then divide by 4. So what I actually get is W equals 13. I've found the width is 13, so the length must be 13 plus 14, which is 27. So the area is very clearly 27 times 13, 351 centimeters squared, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.